Find all points having an x-coordinate of 2 whose distance from the point -2 and -1 is 5. So let's start with a graph. So now that we have our graph, let's put our pertinent information on. So let's put our point on -2, -1. And then we're looking for all points having an x-coordinate of 2. So all points having an x-coordinate of 2, this is our x-coordinate, would be all these points going infinitely up and infinitely down. It could be any of those points. So now that we have those 2 bits on the graph, let's start by let's start testing. We have really 2 possibilities. It's either a straight line, in which case there's 1 point, or there are 2 straight lines, or there are 2 diagonal lines, one going this way and one going this way, in which case there are 2 points. So let's start by testing the straight line. So between this point and here. So here we have an x of 2, but we're level with this point, which has a -1y. So this point right here is 2 minus 1. And to figure out this distance, we could do the distance formula if we'd like, but it's simpler just to count 1, 2, 3, 4. So this has a length of 4, which is obviously not 5. So this is not the point we're looking for, which leaves us with only one option, that there are 2 points. One diagonal line going up this way, and one diagonal line going down this way. We don't know what the angle of that line is, but we know the distance. So let's just put an arbitrary line. And we don't know the point. We know the x-coordinate too, but we don't know the y-coordinate. So let's just put y. And then this distance is 5. So this is an unknown distance right here. We're looking for this distance. And we have the same thing going down in this direction. 5, and again we have 2 and some unknown y. So if you notice, we have a triangle, or 2 triangles. 2 triangles that are exactly the same, that are just simply reflections of each other. But not only that, we have a triangle where we know 2 sides of it, which is going to allow us to use our Pythagorean theorem, a squared plus b squared is equal to c squared. So in order to solve this problem, we're going to need to find out what this length is right here. If you can see, we know this point right here. This is 2 minus 1. So in order to figure out what this point is, which is what we're looking for this point's distance to this point that we don't know. But in order to find out this y, we need to know this side. This y is this point plus whatever this side would be. Let's just call the side A. So this side A. So we can actually change this unknown point to 2 to -1, because this is where we're going to start from. It's -1 plus A. -1 plus A. And then this point, it's going to be the opposite, because we're going to be going in a downwards direction. So this is A as well. So both of these triangles are exactly the same. Again, they're just simply reflections of each other. So this point is going to be 2 minus 1, which is this point right here, and then we're going down by A, minus A. So now that we know what we're looking for, let's go ahead and use Pythagorean theorem. So we have a squared, which we don't know, plus 4 squared is equal to c squared, which is 5. And it's critical here that you don't mess up with Pythagorean theorem. Remember, c is always the longest side. And in this case, here's our right angle, So that means C is here, 5. Remember, the hypotenuse, which is just a fancy word for the longest side, is always opposite of the greatest angle. And if you don't believe me, just draw random triangles and you will see that the longest side is always across from the biggest angle. So just make sure that you don't mess that up. The A and B is not important, it's just important that you get the C right. So let's go ahead and solve for this. A squared plus 16 is equal to 25. A squared, so we subtract 16 from both sides, is equal to 9. We take the square root of both sides. So A is equal to 3. So we found out that A is equal to 3. So again, it's a simple matter of going to this point, which we do know its location, 2 minus 1, and for this point we're going to add 3. So minus 1 plus this side, 3. And that's going to leave us with 2, 2. So minus 1 plus 3 is just positive 2. And for here, this downside, we're going to be subtracting because we're heading downwards. So that's going to leave us with 2 minus 4. So we have minus 1, we go down by 3, we have minus 4. And those are our 2 points. 2, 2, and 2 minus 4. And if you want to double check, we can take this point right here and put in the distance formula for both of these points. So if you take this point and then put it in the distance formula for this one and this one, it should be equal to 5. And that's how you check your work.